So welcome everyone. My name is Paul Briscoe. I'm in Toronto, Canada, where it's sunny and warm, and we're not as locked down as we were a few weeks ago. And joining me today is my good friend and colleague, Tomer Schechter. He's in Tel Aviv. Tomer, go ahead, say hello, introduce yourself, tell us who you are.
Hi, I'm Tomer Schechter, one of the founders of TAG, and I'm here in Tel Aviv. It's still sunny here. It's the afternoon.
Oh, nice. I envy you. Your day's already over. Anyway, today what we want to talk about is, of course, IP. We're all about IP, and we're going to talk about IP in our ecosystems. And specifically, we're going to talk about what new IP-centric technologies are most promising for broadcast, especially for live production, because that's, we were just talking about OTT before the top of the hour, and that's pretty easy, and that's all kind of working. But COVID has forced us all to think about how to produce in a different world where we can't be in our brick and mortar office or in a mobile truck. And of course, everybody has scattered home, and all manner of remote production started getting glued together the following week, pretty shaky, with people holding up cell phones for cameras and so on. And over the weeks, it's matured rapidly to the point where it's actually full production value TV shows that are being produced in the case of the US live talk shows. So that has forced the discussion about IP particularly, because IP brings flexibility. And we're going to talk about that. We're going to talk a little bit about the technologies that are appropriate and most suitable for doing this. And we're going to talk about the latest technologies, because when we say IP is already getting old in our world. OTT, of course, is now very mature. Regular distribution by IP has been around for a while. And in fact, 2022-6 SMPTE SDI IP is now quite mature, as is 2110 becoming. So we're going to talk a little bit about what's sort of next and what are the enablers coming. And finally, we'll talk about the benefits. How does this actually benefit you going to IP? Because a lot of people are a little tenuous about IP. They know it's coming. They know we have to all get there eventually, just like we all left analog. And we have to come up with, a sufficient number of benefits in each case to understand why it's time to go to IP. So we'll talk a little bit about that. We're happy to take questions throughout this presentation. We have a chat box going in the Zoom meeting here, and our questions are being curated by our lovely colleagues, Dana and Cindy. I don't know if I should call them lovely or just fabulous, because they're just the best people to work with. So if you type a question in the chat box, we'll have an opportunity at the end to answer those for you. Tomer, why don't you do a 30-second quick backstory on TAG? Why in the heck is TAG here anyway, and what have we done and where are we going?
Okay, so TAG was founded about 11, 12 years ago. We started as with developing solutions for transcoding for transport streams. Initially, we came from a DSP development arena, and we thought of developing a transcoder based on an array of DSPs. And then we said, no, maybe we can do it on a PC. It's less expensive, and we can. It might work. So the first prototype was based on two PCs, one doing the decoding and one doing the encoding. So this is the base for the technology.
Wow.
From there on, we started with the transcoders and stuff. The market wasn't really there for us. It made some money, but a lot of competition, and we like to do things differently. And then we found ourselves going into the multiviewers and monitoring part. It's a combination of, well, you need two things. One is flexibility, because unlike devices which are doing a specific process, here you need to be able to change and adapt to different type of sources and workflows of customers. And this is a place where software has a huge advantage over hardware devices. So for us, in those early times, it was a better fit for our technology, not competing with hardware on transcoding. And from there, we, along the years, added more and more features and went from the TS, monitoring transport stream, more to the OTT, and in the recent few years also to the uncompressed over IP, putting a leg in the production side of things.
Very nice. And of course, you failed to mention, because this is software, it doesn't really have anything to do with a computer that's sitting in a rack somewhere that you own. The beauty, of course, of doing this all in software is that great foresight on our part, because with the cloud evolving, the cloud arriving, very same stuff can go there as well as in your basement. So it's a really good story. So tell me why not SDI? I mean, I can actually tell that story myself, but I'd rather hear it from you. Well, what's the limitation of SDI? Why do we want to take a beautiful baseband digital system and replace it with IP?
Well, first of all, you can take any SDI facility and lift one of the tiles of the floor, and you see the spaghetti underneath, and you can, guess what is going to where. So this is the first reason. IP gives you the ability to mix together high amount of content onto a single fiber. It gives you the flexibility to change your workflow overnight. You don't need to put cables. You don't need to do anything. It's really flexible. You can use different content types on the same transport, the same fibers. And of course, the main reason for anybody to go to IP is the transition to COTS, to software. This enables the usage of software, of not dedicated hardware, like off-the-shelf hardware, having software running on servers, having specific softwares doing your specific workflows, not having to build everything from boxes of hardware. And of course, it also enables you to go and update the system over a shorter period of time, shorter intervals than usually you need to do with the hardware, where you have to really replace hardware devices.
Right, but okay, so you're talking to me though, I'm an old SMPTE guy, so we have SMPTE 2022.6, it takes SDI, it pushes it over IP. What's wrong with that?
First of all, it's not so bad. It's doing the job. It's very good if you want to move an SDI from point A to point B. Since it's a full SDI encapsulated, it takes it as is, and you get it on the other side. Now, if you want to change something on the middle, let's say add closed captioning, you can't. It will be very difficult, and of course, your closed captioning inserter will have to receive this 3 gig of transport and add a few packets of closed caption and re-encapsulate it and send it to the other side. So it's not really useful if you're on the production side, if you want really to touch the content. But if you just want to move a content from point A to point B, yeah, you can use it, and this is what it's good for.
Right. So, of course, at SMPTE, we foresaw that, and we developed SMPTE 2110, which dematerializes the streams into video and audio and metadata types, and treats everything as RTP packets on the network and synchronizes them with PTP. So, in a nutshell, how would you describe the opportunity that brings?
Well, with the 2110, you have lots of opportunity how to use the content, because it means that you can ingest everything from the cameras direct into the switch and then do the production in a different building. You don't have the limitations of the SDI, the repetition, the RF issues. It's not existing anymore. So it means that you can have studios in the basement and guys doing the production in the offices 40 floors up and so on. It's really flexible. You can also change the workflow quite easily, because you can have more cameras, less cameras, more sources, less sources. You can combine together different type of sources. And of course, you can handle the audio completely separately from the video and combine everything in the end for the encoders.
So it's bringing us flexibility and agility, which is really important. And of course, you talked about the basement, you talked about the offices 40 floors up, and you forgot about the even higher altitude office. But of course, because we're in software and because we're on IP, we fit the cloud. So, you know, it's a brilliant thing. And in fact, when we did 2110, I'm not sure we saw completely down the road to the fact that we'd be in the cloud this soon and that stuff would move so quickly. And we certainly are seeing 2110 evolving very rapidly and at a pace far greater than we've seen 2022.6 grow. So, I mean, this is really good. So as a customer, if I was a customer and I have a big SDI plant and a lot of experience, how do I dip my toe into IP? I mean, how big a commitment do I need to actually begin to enter the world of IP? Do I actually have to just build a new building and move my staff over and jump in the water?
Well, if you want to get rid of the spaghetti underneath the floors, then probably you should build a new building. But no, you have different ways to go into the IP. Of course, it depends on what you're trying to achieve. If you just want to start learning the new technology, then you can just build a studio or two based on IP technology and do some gateways between the old facility and the new part of it. Go into the and see how it goes. If you want to build something completely new, then you start thinking about the orchestration solutions. And then it's a completely different issue because some customers want to keep the same orchestration, same workflow. And while other customers want to utilize the new technology and the new flexibility, and they don't want the same workflows. And then you have to think, what are the workflows that you want? Because suddenly you can do so much things and to do it so differently because of the different flows, the audio and video going separately, because of the flexibility of the IP over SDI, taking content between different regions and so on. So suddenly the whole idea is completely different. So it depends what you're trying to achieve.
And what if I don't know, though? What if I'm a big customer and I have multiple network facilities or stations I own or something? It's a huge risk to take one of them and simply hump it over to IP and hope it all works, especially 2110, which sounds awfully complicated. I mean, is there an opportunity to experiment? Is there an opportunity to play with this stuff? Or do you really have to jump in with a huge capital expenditure just to find out?
No. First of all, I always suggest to start small and to learn the technology. The issue is, first of all, there's lots of building blocks that you need to understand in order to really swim in this technology. So the best way to do is just purchase a few gateways to convert from SDI to IP, back from IP to SDI. You can purchase a small, not expensive switch. You don't really need the $10,000 switches in order to do a small POC. For a POC, you can really go small. Just have 8 cameras going with IP over converted to IP, going to a multiviewer, going to some screens, learning how it works. Of course, if you want to do a real POC, you need to take a real switch with some orchestration system. But this is, again, you do it in steps. And if you're a big vendor, a big customer, I would suggest to build a whole studio, a single studio based on IP, really try and produce something, understand both what are the issues, the problems, but also what are the new advantages that you can use. Because if you're building a whole facility based on the knowledge of what you can do with the previous generation SDI, then you're just changing the cables, the SDI to fibers. Yeah. But you need to really understand what you can do with the technology in order to plan ahead what you can do in large sizes.
Right. And, you know, it's if you're more than just, say, a mobile truck, it's an even bigger implication to you because you may likely already have IP-based playout systems, for example. You may have some over-the-top or live IP distribution in your system. And so you now have a production system that literally can plug together with it. You don't necessarily have to have that one box in the rack that connects your live studio to your distribution system. It's beautiful that it's all one infrastructure. But how about the complexity? I mean, do you think people are really ready to sit down and dematerialize their workflows so they can actually understand the benefits and the new things they can do? Do you think we're there yet?
It's a process like any new technology. We've seen it in many other fields which are not related to the broadcast. It's like sending an email. You know, in the past you sent a mail. Nobody sent an email. Today, you wouldn't consider sending a mail in order to send a message. So it's the same. If you 5 years from now, you wouldn't even remember the SDI. You would remember the SDI, but will not do anything new. I think that about 6 months ago, we talked about it here in the office and said, yeah, what's the worst positions that you can be in is having to build something from scratch right now. Because if you're going to do it in the safe way, you're going to SDI, but then you're starting with something which is obsolete. Right. And if you're starting with IP, again, 6 months ago, you're starting with something which is, I wouldn't say half-baked, it's baked, but it's, you know, it has its issues, it has its complexities. You need to educate the engineers, the employees, everybody needs to understand all the fine details of everything. Even here in TAG, we had, when we started working with the fibers and everything, we had to, more than once we bought the wrong type of fibers, wrong connectors. You need all of those adapters, all of the small details, letters. It takes time to understand it. Today, you drop an SFP on me, I immediately know what it is and how to use it and what it can do or can't do, but you have so many different options of equipment. And in the end, if you're a video engineer in the field, you can't just take the book out and, what SFP I need. You need to know it. You need experience. And if you just jump into it, those small things can cause a huge pain. So there is a learning curve.
Yeah, no kidding. I mean, we literally in broadcast, especially with SDI, where everything came down to a BNC connector, audio, timecode, everything on a BNC. We went from one connector to many possible connectors and wires and things that can be on them. I mean, people struggle, I think, sometimes to understand that they hold a fiber in their hand, and it's not just one video, audio, and metadata path. It's many bidirectionally, and it's your intercom could be on that. I mean, the richness of these interconnects just it enables you to think so differently to the point where you have to rethink how you build system drawings, because now you have multiple layers to your system drawing. There's how it's wired, there's how it flows, there's how the content is used on top of the the cloud of flows. It's a whole new thing. But the beauty that I see in this is that it enables these new workflows. It enables people to start thinking about just I can't get a cable from here to there. I need a reclocking DA to go 600 feet. Blah blah blah. Just all these funny things we had to learn to make old technologies work, and those now suddenly come from the IT department. Not to say the IT department, but from their world of technology. And the COTS thing excites the heck out of me, because now, rather than being on the growth curve of technology of the broadcast specific hardware and software manufacturers, we're on the growth curve of COTS hardware for compute. And that's Moore's Law, that's smart people, that's driven by a lot of things far bigger than any industry we're part of. So that excites me. And then it connects to the cloud, because people who build COTS hardware are now chasing the cloud, where COTS hardware now becomes virtualized. So, we're seeing multiple generations moving ahead of us, which is great because our technology fits inside all of this. So this all speaks again to flexibility, agility, and just speed of being able to execute change and do things without pulling cables in the floor. Talk to me just a little generally about redundancy in IP, because in SDI, if you want redundant paths, you have to drive two paths, and you have to route two cables and have some kind of little redundancy switch just for one path. In IP, we can have link redundancy, switch redundancy. Just talk briefly about how robust that is.
Yeah, so when we started with the 2022-6 a few years ago, on our first deployment, the plan was to have a -7. -7 is a full redundant path. It means that you have a separate network, additional switches, everything is doubled. And at that point, the switch was very expensive. It was something like $250,000 in this deployment. So we said, it's insane, it's a huge amount of money to put on a redundancy in this case, and there must be a different way to do it. But there isn't. This is the way to do it. But of course, one of the nice things about COTS and using this data center technology is that the same switch that cost 2 years ago $250,000, now it's $10,000. So now having a redundancy of the whole network for those amounts, it's not such an issue. And for this, you have a full 100% foolproof redundancy, which gives you this a much higher levels than any protection or redundancies that you used to have on SDI.
Yeah, no, absolutely. It's again, we're cantilevering off somebody else's world of capability and just applying it to our needs. Yeah, I want to touch on two more things while we're on the call here today. One actually has to do with the difference in evolution of product and evolution of capability of products in software versus hardware. And I came originally from a hardware development world, and we would have hardware development cycles. And of course, in that era, there was software running on this stuff to evolve its features, but there came a point where you had to spin hardware to get more capability as hardware technology improved. Talk to me about the customer advantages of being in the software world, where development is not constrained by things like bills of material and supply chains, and just that whole rigorous and rigid development paradigm.
Yeah. So as you probably see, you don't get a lot of software upgrades for your printer or for any hardware devices. And on your mobile phone, every night when you go to sleep, you see 30 new updates. All of the applications have new updates every day, every 2 days, I don't know. In the end, you look at the update, you don't really see a difference, but somebody is happy with this update, probably. Otherwise, nobody would put the effort. This is the advantage of a software. You can have shorter cycles of development. You can release software with dedicated features, with dedicated solutions. every software vendor has a cycle which is between days to weeks to a month. I don't think that everybody is using a longer cycle than a month to release new versions of software. When you're talking about the software for COTS platforms, when you're talking about hardware, it's years. It's, oh, you need this new feature. Yes, we have it in QA. You'll get it next year on the version of 2021 or something. So this is the main difference. And for the customer, this is a big advantage, meaning that you have a short cycle for getting what you need. You don't need to wait so much. And of course, you also can push the vendors to develop things that you see them as required. It's not just what the vendor would like to develop. You have a say also because it's not such a cycle which takes years. Also, the rate of changes, not just in, when you have releases, the technology goes very, very fast because you have a lot of common points with data centers technology. As we said, the speed of the network interfaces along with the software packages that come along with it, a lot of open source packages that vendors can use in any kind of ways, lots of references, cooperation between different vendors. When you're a hardware vendor, you can't cooperate with another vendor and get a part from him. In our case, we are cooperating with other vendors. We're getting software packages, libraries, including it in our product, and suddenly we have a product which is doing two things at the same time.
It's so brilliant. And, a whole other little thing comes out of this, which is very interesting because it's been a very long time since the actual end user was able to touch the essence. And the way I mean that is there was a day back in analog video where in your local little shop in your place, you could build a little electronic gizmo to do some video thing or some audio thing. And with the advent of SDI, that really just went away because that was beyond the capability of most people's sort of backroom labs. All of a sudden, we're in a world where you can write your own software to actually work on the media, depending on the capabilities in your company. And, we have encountered customers, and I have friends who are working in broadcasting environments who are writing their own code to do things, and ran into several during COVID here who've actually written little small applications to do simple switching and splicing and transport streams and things like that, just to accommodate their remote production needs, special funny audio mixes and things like that. And they're just writing this code themselves on PCs, and this is revolutionary. I mean, this has never been seen. The only time I've encountered this is in the early days of computer graphics, when the best computer graphics artists were the guys who actually wrote their own code and algorithms and routines, right? So, that's a whole vast thing as well, which we don't even see the end of.
Yeah, for this, I think that, today still you don't have any references for open source, for uncompressed, because it's a new technology and it's still, new. But I believe that within a year or two, you'll start to see a lot of implementation for open source, for packages, handling content in uncompressed. And then it will be easier for end users to combine different building blocks in order to achieve different products, different things. I also think that it will come along together with the support of uncompressed on the cloud, which is something that today is still in the oven. Everybody's talking about it, doing some evaluations, but it will take a few more years until it will be fully baked. But I think that it's two things that are developed in parallel, and they probably will be ready in the same time.
Sure, and live production for the cloud, I'd love if we could have delved into that today, but that's a topic for a different day because there are many things, and it's advancing rapidly, that I think would be useful to share. But I'd like to just touch on one more point, if you could extrapolate a little bit on this. And it wouldn't be right if I didn't put in a bit of a plug here somewhere. With software, of course, we have this beautiful opportunity of dynamics. We can run it wherever we want, whenever we want. And really, it comes down to a matter of licensing. It's not like you're buying 10 boxes that arrive on the shipping dock and you know where they are physically. With software, you're buying 10 instances of software. And really what you're buying is an instance of software and then 10 licenses. Can you just talk a little bit about how that model of flexibility can be used to allow a customer to maximize their investment? So meaning, if rather than having 3 boxes in 3 racks, there's one ghost box that virtually moves from rack to rack. by virtue of it just being software and its enablement through licenses?
Yeah, so we also started with this approach when we started, flexible licenses, license sharing, license from the cloud, all of those models, which are quite common at the high-tech industry, not on the video industry, because you had boxes, you always had boxes. You can upload maybe additional licenses, but it's a process that you're doing. It's not on the fly. But we started to work initially with teleports, and teleports has usually facilities in different regions in the world. And they always wanted to move stuff between different regions because you have the Olympics and then you have some soccer match and so on, and they wanted to move licenses, and we had to develop tools to handle dynamic license changes. So this was a very basic part of our model. Recently, we also introduced the zero friction licensing, which is also the ability to change what the license is doing, because customer already bought the licenses, and now he wants to do a multiviewers, and he can use it to do a multiviewer. And tomorrow he needs to do some transcoding, maybe create an OTT channel out of the content, or do some other issues, some other processes. And he doesn't want to handle licensing all the time. It's not. It slows down the process. So the idea behind this is to just use those licenses for any kind of task. The same way that you're using AWS instances. You pay as you go, you buy some licenses, and you can use it. And you can use it for a web server, you can use it to an email server, you can use it for transcoding, you can use it for whatever you want. So it's the same idea. And the idea is, again, give the flexibility and the highest, mainly flexibility and the lowest waste of time for the customers.
So that's how our licensing model works then. You can actually move your ownership of licenses between instances of tag on premises, in a truck, on the other side of the world, in the cloud. It doesn't really matter. You can keep all your licenses engaged in activity 24/7 if you choose, rather than something going dark except for the 1-hour news show every day. That's pretty flexible. That's a pretty advanced software model too. We don't see that in a lot of places yet, but it's certainly software as a service, and licensing is the model of the future for sure.
Yeah, thank you. I believe that in the end, all of the customer will expect to have the same level of flexibility and ease of management as they get in all of the consumer level devices, same that you have on your cellular phone and your regular applications. If you get it on your mobile phone, why not having it also on professional products?
Well, there's a topic for another day as well, because that gray line between your mobile phone and a big professional camera is getting thinner every day, and that's a whole commodification conversation we'll have another time. Probably we should think about wrapping things up here. And so if we have questions in the conversation box there, we'd be happy to listen to them and do our best to answer. I will throw in a couple little data points here. If you want to play with IP, you might want to give us a call. We offer you free proof of concept trials of our product. And it's a very, very simple thing to set up. And if you contact us on a Tuesday, you can be up and running on a Wednesday in the cloud or on a server in your own premises, and start playing with IP. Pretty much any format that goes over IP is accommodated. So please, by all means, feel free to tap us if we can help you. The other thing I'll mention, and thanks to COVID, is SMPTE, the Society of Motion Picture and Television Engineers, has made a number of their online courses reduced cost or free, as well as some of their standards available for free during COVID as an incentive. And I would encourage people who want to learn more about 2110 to go over to the SMPTE website and have a look at what's available in their educational offerings, both for free as well as paid courses. These are online courses, they're curated courses, and they're very, very good, and they're a great opportunity to get yourself over the hump in IP. So Cindy, have you got any questions?
We have questions for you. How you doing, Paul? Hey, Tomer. All right, we've got quite a few questions for you, and the first one is, can you give me a little more detail on the minimum requirements for 2110 POC?
I can start that. Maybe Tomer, you can fill in. I mean, if you want to do a little POC, you need to start with the basic core, which is a switch. It's got to be a switch capable of the interfaces you need for the speeds you're running. So typically that would speak to 10 gig fiber at a minimum if you're running baseband video. You need a PTP Grandmaster although depending on the switch, if it's a boundary clock switch, you can actually get by without a PTP master because it will kind of work like one. You'll need some gateways to get your existing signals into 2110 from SDI. These are made by a number of vendors. And the same, you'll need some gateways to get signal back out into your SDI format to put on a scope or to interface to your system to test workflow. Multiviewer is really a great thing to add to a proof of concept only because you can look at everything simultaneously on the multiviewer. You can make measurements, you can do diagnostics, you can trap alarms and so on. And that would be, in my mind, a basic system, a switch, timing, sources, destinations, and a multiviewer to look at it all. You can always convert back to SDI and look at a scope, or you can get yourself a 2110 scope as well if you're still in the scope state of mind, something we're moving away from more rapidly. Tomer, what would you add to that?
Well, there are a few technical details, like in order to use our product with uncompressed, you also need a network interface card supporting it, like a Mellanox 100G card or a 25G. On the switch side, as you suggested, you have the large professional switches, which are expensive, not too much for broadcasters, but sensible. But if you even want to do it at home, this is, for example, a $100 switch from Amazon, supporting up to UHD 10G feeds in 50 frames per second. It's $100 on Amazon. I'm not trying to advertise the product, but it just shows what happens when you have the video industry going along with the data center industry, the commercial industry. It means that everything is really, really accessible. You know, I don't want to do advertisement to Amazon, but you order today and you can be up and running in a few days with the whole setup in your home during the COVID. So it's really flexible. I think that this is the main difference between today and 2 years ago. 2 years ago, to get a switch that can do uncompressed over IP, it was like you need to have a phone call to a friend who knows somebody who can give you a prototype. And today it's off the shelf, it's tested equipment, it's very easy to go and start. Any question regarding configuration and stuff, you go into Google and you have the answers already because somebody already did it before you. So it's really easy to start playing with it.
Nice,
Fabulous.
nice. Can I follow that up, Tomar, with a question that we have from one of the attendees here? And he said that he shares Paul's excitement around COTS technology. Since you're talking about ordering from Amazon, this question seemed to flow in nicely. And he wanted to know specifically, are there minimum specs for switches to handle SMPTE ST2110, especially SMPTE 2059? And are there any recommended sources for quantifying those minimum specs?
It depends. In general, most of the recent equipment will do the job for a small POC, but it starts being more complicated when you have a larger amount of sources. When you only have 2 cameras going on the switch, and the switch, even if it's not a good switch, it will handle everything. But if you're pushing 30 cameras or 100 cameras, then all of those issues start to have an effect. And then sometimes you even need different variants of the switches which are oriented for the video arena and not just the data center switches. But usually you get to those places already when you have a large deployment, not just a POC. But for a POC, any recent equipment will do the job.
Great, great. And you both talked about licensing a little bit earlier. We do have a question that came up asking, can you use the same license both on-prem and in the cloud?
Yeah, it's just not simultaneously. You can use one license one time someplace, and it doesn't matter. I won't make a joke about where you can put the license, but you can literally put it anywhere you need to.
Nice. And another question is, are there rules of thumb when calculating the throughput capacity of switches in a spine leaf network before you purchase the switches?
Oh my, well, it's a 2-part question. I'll let Tomer talk about the backbone part of it. The one thing about links, and this is important to the SMPTE 2110 spec, is we have constrained links to 90% capacity. That's a beta of 1.1. So the links cannot be loaded beyond a 90% capacity to meet the requirements for SMPTE reliability and not dropping UDP packets. Tomer, do you want to talk a little bit about backbone and fabric bandwidth?
Okay, so this is a very complex question. There are different topologies for how to deploy large networks. One of them is spine leaf. Another one is to have a huge monolithic switch, which is, again, another option. And another one is software-defined networking, where you have a mesh of switches and some logic above it, like ways for data, telling each stream what is the best way to get to the other side. I would say that for large deployments, this will be the most effective, most difficult, but also most effective way, because with a mesh network, you can replace parts of the network and you can upgrade the network quite easily. With a monolithic switch, meaning that you have a single huge switch, you pay a huge amount of money and then one day it's worthless. So it's the worst option looking to the future, but again, it will give you the immediate, simplest solution, because you just plug it to the power and that's it. You have whatever you need. It can do whatever it can do, and that's it. And spine leaf, it's something in the middle. It means that everything is going through the spine. It means that you need to plan in advance that will have the bandwidth in the connections to the spine. It is, I'd say, that the solution in the middle, not too complicated, but also not useless in the future. So again, it depends on the size of the deployment and the level of management that you would like to put into it.
Yeah, and I'll add that this is where broadcast engineering runs into IT quite head on, because this is expertise that exists in the IT world and doesn't exist right now in the broadcast world. And of course, there will not be in the future two separate worlds. There will be specialized IT broadcast engineering, and it will exist in that domain. But right now, this is IT magic as well, because your typical IT person, let's remember, every data center in the world today has packets spilling on the floor all day, all night, because everything's running TCP. Packets get lost. They don't get lost. They just get retried. These systems are UDP based, and this is a whole new kind of IP where you cannot drop a packet on the floor. So IT has frankly had a free ride for decades thanks to TCP, because even if you have bad connections, it all still works. Maybe a little more slowly, maybe some more retries. You don't care. The phone doesn't ring. You drop IP packets on the Super Bowl, and someone's going to phone you, and they will not be happy. So IT has a whole big thing ahead of them to learn as well. But ultimately, what it brings to the table far outweighs the difficulty in getting there. It's really all we can say about IP. As far as the bandwidth goes, we also know, I mean, I started life with a 300 baud dial-up modem, and I'm on a better connection today, so I can only tell you, no, Cindy's waving and pointing at her. She's still on a 300 baud connection. But things just keep getting faster, right? So we're all riding that curve instead of our old SDI coax cable curve.
A really great question came in asking what streaming technology is used to move video within the cloud to the tag Multiviewer.
Within the cloud?
Yeah.
I don't know, Tomer, you know the NDA status on this stuff better than me, because this is all breaking news in the cloud domain. I'll defer.
I can answer it without answering it. In general, in the cloud, the limitation is that you can't really support a multicast. You can support a multicast within your private network on the cloud, but you can't support multicast in order to get content to the cloud or between different private clouds instances. So you have to do a point-to-point streaming, which is not so effective if you have to send a stream multiple times. Let's say I want to uplink a camera and I want to do it in the backup uplink to two places, and suddenly I have a huge amount of information that I need to upload. There are a few protocols for doing it, like the ZXC, SRT, and the RSIT, encapsulating transport streams with some error correction, with some logic how to find the best path to the instance on the cloud. So this is one of the ways to get content to the cloud. Those protocols, I don't know if they're supporting uncompressed or not, but today it's not really relevant because nobody has this bandwidth, the connection of this. You have it for POCs, but not in real life. I had a conversation with Paul a few days ago about it. And I told him, yeah, it's in the future. It will take years, and at least 2-3 years. And then I got myself, 2-3 years. It's not so much in the future, but today it's really not. You can't send uncompressed to the cloud, not really, but it is only a few years from us.
You know, there's a flip side to this too. We've always worked in uncompressed because we could. So if we go back to analog video, we fit the whole uncompressed picture on a coax, and then we went to SDI and we had the same coax, so we just did the same thing, and we went to HD and we still had the same old coax, well, better coax maybe. And we've always just done it because it just plain happened. But in IP, there's two things. It becomes burdensome to transport this much data today. It'll get better in time. But the reality is, with technology of compression, mezzanine compression today, we don't need to transmit these pixels. We need to transmit an artistically sufficient image, but not every single pixel. And so the uplink, downlink to and from ground to cloud can get looked at in a different light. We don't have to use the same old 50, 60-year-old baseband pixels anymore in our systems. And this may lead us actually to more efficient production workflows. I mean, there's people doing TV shows from Zoom meetings right now, and you look at them on screen, you go, well, it's not the best camera in the world, but is it broadcast quality? Well, I'm watching it along with 5 million other people. I guess it is. So much is going to change that these questions actually change. The reason I mentioned NDA is that there is activity going on in the different cloud providers to deal with moving big stuff around in a timely way inside the cloud. I'll put it that way. PTP in the cloud isn't necessarily the easiest thing, but it's another story. If we're in 2110, we kind of need PTP because it's a very hardware-centric software standard. If we get a little bit away from that, we really don't need PTP for low latency live production. So getting it in the cloud, while theoretically a requirement right now, we can apply a little different thinking to what we do and make that need go away, which would be wonderful in the whole world, frankly. We don't need 100 nanosecond accuracy in our systems. That's just a carryover from the old days, frankly.
Wonderful. Well, Tamar, Paul, thank you for talking about new technology you need for your IP migration. And for all the questions we didn't get to, everybody, we're going to take those offline and follow up with you afterwards. So we'll be sure to follow up with you. Thank you. I'll turn it back over to you, Paul.
Oh, thank you, Cindy, and Dana as well, helping you out there in Tel Aviv. And thank you, everybody, for joining. Again, I'll remind you, if you want to play with IP, we'll give you one to play with. And what it is a software license to start up a software instance. That's as hard as broadcast technology gets nowadays, or at least with TAG. And as well, check out the SMPTE website. There's education available. SMPTE is a great organization to belong to. And if you think you have something to contribute, we'd love you to be involved in SMPTE standards development. Thank you all for your questions. Tomer, a pleasure like always to chat with you. And we look forward to seeing you all next time.
Thank you.